Now it's working. This is really weird that they have, okay, 2 red dots at the same time. So we want to, oh my goodness, determine the length of PQ. If we were using letters, little letters, would you agree that you would use little letter r to represent P to Q? Always label your hypotenuse. And then you can decide, based on the angle that you have, whether you're going to use sine, cosine, or tangent. So I have the angle here. I know the hypotenuse. I'm going to scroll up so we can see the SOHCAHTOA. The r, compared to this angle, is the opposite of that angle. So we need to use sine because we want to find the opposite. So we want to find the opposite means that we either want to use sine or tangent, but we would need to know either the hypotenuse or the adjacent. We know the hypotenuse, then we'll write out our sine definition. And our sine definition says sine of the angle is equal to the opposite side over the hypotenuse. And then our job is to use algebra to get the variable by itself. This is the easier one, since the variable's in the numerator. How could I get rid of the 10.4? Multiply both sides by 10.4. If I multiply that side by 10.4, it'll simplify away. And then I have r all by itself. And I can go to my calculator and I can type in 10.4 sine of 67. Oh, and I realized just now that if I push enter, I will get a different answer than you will get. Everybody should not get this answer, -8. Why? I am not in degrees. So sometimes our calculators get switched out of degrees, especially if you're sharing with an older sibling who's taking grade 12 math, because in grade 12 math we use radians a lot. So now I just have to retype this now that I'm in degrees, and I get 9.57 to the nearest tenth, 9.6, add our units, circle our final answer. And so trigonometry, really nice, because you just have to analyze the situation to figure out which definition you're going to use. Sine definition, cosine definition, or tan definition. Then you write out the definition with the numbers that you have. Sine is the opposite over hypotenuse. And then you use your grade 9 algebra skills to get the variable by itself. Determine the length of JK. What letter would I use for JK? A little m. Okay? Are you okay that m is actually the hypotenuse? So in SOHCAHTOA, definitely is not going to be tan. It's got to be either sine or cosine because we want to find the hypotenuse. Okay? Angle is 65. So this is opposite. Again, we'd have to use sine. So our definition of sine says sine of 65 degrees is the opposite side, 7.6, divided by the hypotenuse, which is m. This one's a little bit more complicated. We want to get the m by itself, but right now it's in a denominator. So even if we got rid of the 7.6, the m would still be on the bottom of that fraction. So we take our time first, multiply both sides by m to move it to the top. These ones would cancel. Now I could divide both sides by sine of 65 to get the m by itself. Go to my calculator, 7.6 divided by sine of 65, 8.385, nearest tenth, 8.4 centimeters. Yeah, divided by sine of 65. Again, you should be typing these into your calculator as you're going to make sure that you're in degrees, to make sure that you're seeing how to do this on your own. Word problems that you have to draw a picture a little bit harder. Okay? So we need to draw a picture that, there we go, I'll move that up. From a radar station, the angle of elevation. How do we calculate angle of elevation? Horizontal line looking up. So we've got an angle of elevation of 32.5 degrees to an airplane. I look like a little airplane? Maybe it needs bigger wings. There we go. There's our airplane. Can you see that this makes a right angle triangle? The horizontal distance between the plane and the radar station is 35.6. This is going to be important to interpret. We have three sides of this triangle where we could label that. It's going to be on the bottom. This, the hypotenuse, would be the actual distance. So if they said the distance between the radar station and the airplane, then you would do the hypotenuse. But we also have a horizontal distance and a vertical distance. How far is the plane from the radar station? So where are we going to put our x? What are we trying to solve? This side or this side? Opposite side or the hypotenuse? Because how far is the plane from the radar station? The radar station is right there. So again, how do we know the radar station is right there? It says from a radar station, the angle of elevation. So that's telling us that where that angle is where the radar station is. So again, the math now isn't going to be too hard. The hardest part in this one is, can you draw an accurate picture of what's happening? Now that we have an accurate picture, we go to our definition of SOHCAHTOA. And which side do we want to find? Label our hypotenuse. We want to find our hypotenuse. So it's either going to be sine or cosine definition that we write. And this time, since the 35.6 is the adjacent to the angle, we will choose cosine. So cos of 32.5 degrees. The adjacent side is 35.6, and what we want to solve, we put as the variable x. This is what we want to solve for. It's on the bottom of our fraction, so we have to take a step first to multiply both sides by x so that we get it off of the bottom of the fraction. And then you can divide both sides by cos of 32.5. Go to our calculator. 35.6 divided by cos of 32.5. 42.2. What does it say to round to? Nearest tenth. And our units are kilometers. And again, this is all possible because your calculator has all of these ratios memorized or pre-inputted. Okay? It's a whole nother math question to ask, how does that get all into the calculator? Does it have them like stored for each one? But you can write so many decimals, they'd have to store so many things. Or is there a way that the calculator is also taught to calculate it so it can figure it out quickly each time? We're going to have time at the end of class to work on this assignment and the one at the end of these questions. I'll make 2 little videos though.